This is the fourth video in Mr. Loftus's National 5 Maths Percentages series. The third video focused on compound interest and a little bit of population modelling. And the fifth and final video will focus on just some past paper examples and preparing pupils for the homework exercise and ultimately finishing off the topic and moving towards the exam. This video, the fourth, is going to focus on the following. So our learning intention in this video is quite ambiguously just titled Working Backwards Percentage Problems. Okay, and we'll see how that goes. Basically, the logic of saying that we're working backwards is because we're no longer starting with 100% as we did normally when we were doing appreciation and depreciation as well as compound interest. We always started with 100%, but in these ones we'll be working backwards to find what 100% is essentially. Okay, so perhaps some slightly counterintuitive examples to come, but if we can keep that in mind that they are supposed to be counterintuitive, hopefully we can then out-intuition the problem itself. So let's have a go at example 1. So example 1 says this. Mr. Loftus received a 10% pay rise and now earns £33,000 PA. Now we remember what this PA means, hopefully. It means per annum, which basically just means each year. So unfortunately, he's not lucky enough to earn £33,000 per week or per month. It is annually, it is per year. Okay, so the question is, how much did he earn before receiving the pay rise? So when you read that, it might sound really straightforward. It might sound really simple. Well, if he received a 10% pay rise, okay, that obviously means it's going up the way. So he's getting more money, and then he's arrived at this £33,000 per year. So if we wanted to find out how much he made before the pay rise, surely you would just take 10% away from that. Well, let's see if that works, and we're going to do it in a little box at the side here. We're going to box this off when we're finished, and I'll do it in, you know what, I'm going to do it in red pen, because red means danger, and this is my mathematician's way of saying don't do this, essentially. Don't try this at home. So if he received a 10% pay rise and now earns £33,000 per annum, well, let's see if that works. So let's take 10% of that. So let's take 10% of £33,000, which will give me, well, 10% divided by 10. Let's just remove one of the zeros at the end, or move all of our figures one place to the right. That's going to give us £3,300. Okay, so if we are saying, well, he had a 10% pay rise, so let's undo that pay rise. Let's take it away. So let's take £3,300 away from me. So let's take the £33,000 and subtract 3,300. So logically that would mean before I received my pay rise, take away 3,000 would be 30,000. Still got 300 to go, so that would be £29,700. So if you did pause the video and you tried that and you got the answer £29,700, congratulations, you've essentially ascertained the sort of right-wrong answer. Okay, you have did your calculations correctly, you've worked out 10% correctly, subtracted it correctly, but this is the wrong method, and I'm just going to again box that off, put it in a bit of a danger sign. Let's not do this because it's not the correct way. We could check that it's not the correct way, because essentially what you're saying is, before I received this 10% pay rise, we're claiming that I earned £29,700. So therefore, if I took 10% of this and added it on, surely that would mean I arrive at my new wage, my 33,000. Well, let's see if that would work. You can do it in your heads. 10% of this would be 2,970, and if I take 29,700 and I add on 2,970, do I get 33,000? No, I don't. I'm being shortchanged £330, so I've got 32,670. So this does not work. Does not work. Okay, it's an invalid method and it's given us an incorrect answer. So we need a cleverer way of doing things. So let's go back over here and let's consider this working backwards part. Now our problem here is that we've essentially assumed that 33,000 is our sort of original amount, or 100% that we usually work with, whereas it's not. It's actually not. The original amount is the subject of the question, how much I earned before receiving the pay rise. So if you want to think of it this way, before I received the pay rise, I had 100% of my wage. Then I get a 10% pay rise. Well, it's going up, so I'm going to add that on, haven't I? 100% plus 10% gives me 110%. Okay, again, remember, if you've heard in maths before, we discussed this in the compound interest video. If you've heard in maths before, well, we can't get more than 100%. You can, it just needs to be in the correct context. Mathematically, more than 100% makes sense. You just need to make sure that your mathematics back it up. Okay, so essentially what we're saying is this amount, my original amount plus my 10% pay rise, is 110%, and that's my new wage. So I can write that down. So I've got 110% is actually equal to my new wage, which is the 33,000. I'm going to drop the pound sign just now, just because it would make these equations look a little bit messier. Okay, so what I'm trying to get is my 100%. That's what I want to know. I want to work backwards to figure out what 100% is, because that's how much I earned before receiving the pay rise. Those are the same thing. So how do I go from 110% to eventually work down here to get 100%? Well, again, the obvious answer would be, well, let's take 10% away, because 110 take away 10 would give me 100. But the problem with that is, if you take 10% away, you're finding 10% of 110%. Now, that might seem a little bit confusing, but if you think again over here, can we see that in the video? Just about. If you find 10% of 110, that's not 10. 10% of 110 is 11. So if you take 10% away from this, you're actually essentially subtracting 11% from it, which is why we got that number of 32,670, because we've taken away too much. So we need a cleverer way of doing things. Well, let's go back to our old friend 1%. It's always useful to be able to work out 1% in a percentages question. Now, how would I go from 110 to 1? Well, you might be thinking you could take away 109, but again, addition and subtraction aren't our friends here, because we're not dealing with a whole quantity. So what we're going to have to do instead is we're going to have to do a little bit of algebra, and we're going to divide by 110, because 110 divided by 110 is 1. And if I divide that side by 110, I must do the same to both sides of my equation. So I'm also going to divide that side by 110. So in fact, 1% is 33,000 divided by 110, which is actually just 300. Okay, now I've got what 1% is. Remember, what we're looking for is 100%. Well, how do you go from 1 to 100? Well, you would times it by 100. So let's now times both sides by 100, multiply both sides by 100. And now that bit's easy. 100% equals 300 multiplied by 100 will give me 30,000. I can just add that little pound sign on at the end there now. So that means, how much did I earn before my pay rise? Well, that would be 100%, and 100% is £30,000. Now we can check this. So let's check if that actually works now, like we tried to do over here and it didn't work. Well, if we check that, say we have no idea about this part, and I just said, okay, I earned £30,000, give me a 10% pay rise. How much is that? Well, hopefully we all agree. 10% of £30,000 is £3,000. So if you add that pay rise on, you'll get a new wage of £33,000. And that works perfectly. Okay. Now, before we move on to a second example, let's just go back to this stage here, because if you didn't quite follow, well, how did we go from 110 to 1 down here? Here's a little way of thinking about it. I did mention some algebra. Let's just take a completely different type of question. Imagine I told you that 110x equals 33,000. How would you get x on its own? Well, you've got 110 x's is this much. So to get 1x on its own, you'll have to split both of these into 110 parts. So you would do this, you would divide both sides by 110, like that. So then x would equal 300. And remember, x is the same as 1x. And if you want to just think of that 1x as the same as that 1%, hopefully that should kind of make sense in your head. Now, it's obviously not just going to be the same for 110. Whichever number you have in front of this percentage, to get 1%, divide by itself. Okay, because if you divide a number by itself, it gives you 1. And that's the useful tool that we're going to use here. Okay, so again, if you need to pause it and ask questions, please do that just now. But if not, let's just move on to example 2, which is obviously going to go the other way. So we have example 2 here. Another common real life type scenario, and let's see if we can work it out. So we've got a jumper was on sale at 20% off. The sale price was £48. How much did the jumper cost before the sale? I should have highlighted that before as well, because we're working backwards. Okay, so a jumper was on sale at 20% off, and we know the sale price. So this is a good type of question, because sometimes whenever you're in a shop, as good mathematicians, if you're looking at different deals, you should be working out, is that really a good deal or not? Is this a good sale? How much did it cost before the sale? How much am I really saving? Things like that. So again, intuitively you'd say, well, it's on sale at 20% off and it costs this much. So let's just find 20% of that and add it on, and that will tell us what it was before. Well, again, that's not going to work for us because of what we showed in the last video. So again, we're working backwards. So what we want to do is we want to start by writing down our 100%. And if it's on sale at 20% off, I'm not going to be adding that 20% on. I'm going to be taking it off because it's 20% off. So let's take away 20%. Again, this bit isn't the trick question or anything. You just need to practice it. So 100 take away 20 will give me 80%. So essentially, this sale price, this £48, is 80% of the pre-sale price, the original price. Okay, so that 48 there is essentially the same as that 80% there. So let's set up our equation as we did before. 80% of the original price is £48, like that. I've included the pound sign here because I've forgotten this time. You don't need to do that. Again, what we're looking for is our friend 100%. That will tell us the original price. How do I get from 80 to 100? The answer is not add on 20. The answer is divide it by 80 and multiply it by 100. So let's get down to 1%. Divide both sides by 80. Remember, whichever number is in front of this percentage sign, if you're doing a question like this, you need to divide both sides by 80. Okay, and that will give you 1% every time, because if you divide a number by itself, it gives you 1. So we have 1% here. Equals 48 divided by 80. You could do that without a calculator, but you'll probably have a calculator for these questions. 3 over 5 or 0.6. So 1% is 0.6. We don't want 1%, we want 100%. What do you do to 1 to make it 100? You multiply it by 100. And if I multiply that side by 100, I multiply both sides by 100. So therefore 100% on the left-hand side equals 0.6 multiplied by 100. Let's not be too lazy there. We can do that without a calculator. Move the figures 2 places to the left will give me 60. So in other words, how much did the jumper cost before the sale? The answer is £60 before the sale. And that is me finished. Okay, so let's just finish highlighting that. Excuse my not very good highlighters. Okay, I think this video, so we're at 15 minutes at the moment. I think I'll just quickly show how the other way wouldn't have worked, because there might still be some people watching thinking, I don't really get that way, I'm just going to add 20% on. Well, it doesn't work, because if we've got 20% off and it's £48, if you do 20% of £48, well, 20% is 1/5. So if you do 48 divided by 5, like so, it's 9.6, or in other words, £9.60. And if you add that back onto that, and if you do £48 plus £9.60, like that, 48 plus 9.6 equals, and you'll find that it tells you it's 57.6, or in other words, £57.60. Well, that just isn't correct. Okay, the jumper, so essentially if you do it this way, if you just try and add 20% back on, you're trying to tell me that the jumper cost £57.60 before. So essentially in the context of this question, it's not as good a deal as the reality as the correct answer, because in this example, the jumper did cost £60, it's now down to 48, you're saving £12. In this one, it's £57.60 down to 48, you're only saving £9.60. And it's correct. It's incorrect to do it this way anyway. So regardless whether it's a better deal or not, it's not the correct way to do it. Again, we can check it further from here. If we take that 20% back off £57.60, it's not going to give us the same answer again, because 20% of 57.6, if we do that, 57.6 divided by 5, that tells me that's £11.52. And if I do £57.60, take away £11.52, 57.6, take away 11.52. Again, it just gives me a completely different answer again. We're now back at £46.08. So you're just making up new numbers all over the place here. Okay, so essentially, again, the same thing. Doing our check, putting it in red pen. Do not try this at home. This is the wrong method. Okay, 90% of the wrong answers that I see for these questions in the homework or in prelims, past papers, things like that, it's because people have done it that method and not used the correct working backwards. Okay, so that is the end of the 4th video on percentages, and that is all of the new material finished. The 5th and final video will be just a couple of selected past paper examples, maybe some hints for the homework exercise, but other than that, that is now the percentages unit finished. You now need to practice, 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 and ask for help.